Now, while we do a lot of calculations in this unit, there are a lot of practical applications for it as well, and this is one of the most important things. And the first half of this podcast is going to talk about making solutions, and the other one's going to talk about making solutions from other situations, so changing concentrations. So let's talk about making solutions. Whenever you make a solution, if you think about it for a second, you do this all the time at home, there are specific steps that you have to follow. So imagine, if you will, you're going to make iced tea. Okay, you're going to make like powdered from a mix. So what do you have to do? Well, before you make the iced tea, you have to decide, how much do I want to make? How much of the powder do I have to put in? How much water do I have to put in? And then there's always a very, very important step at the very end. And I'll talk about that when we get to the end of this example. But all those steps, like deciding what container, deciding how much powder, deciding how much water, is all the same thing in chemistry. But in chemistry, we want specific concentrations. At home, it's like, it tastes too strong or it tastes too weak, so I've got to add a little bit more. So you don't go by your taste, but in the lab, we go with numbers. So this question says, describe how to make 200 milliliters of a 1.25 molar solution of NaCl starting from the solid solute. In other words, from solid sodium chloride. Well, like I said, there are four things you need to do. Number one, determine how much solute. Okay? So I've got to figure out how much solute I need to put into this container in order to make my solution. So let's do a molarity conversion. Molarity is equal to moles of sodium chloride in this example divided by liters of solution. Well, I want to make a 1.25 molar solution, and I want there to be 200 milliliters or 0.200 liters. So I'm going to solve for moles. So 1.25 cross multiply times 0.2 is 0.25. Quick mole conversion. The weight of sodium chloride is 58.45 grams. So the thing I love about these problems is whenever you do the math on the calculator, everything's just sitting there waiting for you already. Times 8.45 is 14.6. Don't circle that because I'm not done yet. Okay? So first thing I just said is determine how much solute. Second thing is determine how much solvent. Okay. I'm going to kind of do this stepwise. Divide this into three things. Okay. Now I have determined how much solvent. So what am I going to do? I'm going to measure 14.6 grams NaCl. Okay. Now, how much solvent do I need? Well, I don't know, because I don't know how much room 14.6 grams is going to take up. But I know I need a total of 200 milliliters. So I know that I've got to put enough water in to make 200 milliliters of solution. So I'm going to hold on to that thought for a second, because here's the thing. You can know how much you need, but where am I going to put this 200 milliliters when I'm ready for it? Number 3. Determine size of your container. Okay, well, I have a 200 milliliter solution. I don't have 200 milliliter beakers in the lab, but I have 250 milliliter beakers. And of course, I don't want to use a 200 milliliter beaker because I don't want to fill it directly to the very, very tippy top. I want to have some space. So I'm going to use a 250 milliliter beaker. So measure 14.6 grams of sodium chloride and put in a 250 milliliter beaker. Now here's the key phrase. Add enough water to make 200 milliliters of solution. You notice they actually say this on the back of the iced tea container. It says add enough water to make 1 gallon or 5 quarts or whatever it's going to be. Okay? And then, of course, the last step. Now, most people forget this last step, but hands down, it's the most important step. So after you've made your iced tea, you put your powder in the container, in the pitcher, you filled it with water. Of course, the last thing you always do is stir. That's right. You must include stir. Because if you don't mix it, it's not a solution. Okay? And this is the correct answer to this problem. Now, obviously, when you write this all out, I want to see this calculation, and I want to see this little description, because it does say describe, and describe means in words. So you're going to have to do the calculation to prove how much sodium chloride you would need, and then you would write out a description. Now, that's great if you're making a solution from a solid. But what if you're making a solution from another solution? Like, let's say, you know, your mom made the iced tea, but it was way too strong. That always happens in my house. I make the iced tea. My wife always thinks it's way too strong. So what does she do? She adds water. She dilutes it. Okay? How much do you dilute it by? Well, at home it's by taste, but in the lab we have an actual formula we can use. The formula you're going to use anytime you're making a solution from a solution is this formula. M1 V1 equals M2 V2. Okay, this is molarity times volume equals molarity times volume. It doesn't matter which one is the 1 and the 2, as long as the information goes together. So whatever comes first in the problem, I always classify as ones. So it says, describe how to make 200 milliliters of a 1.25 molar solution. So my molarity here will be 1.25. My volume, of course it's in liters, is 0.20. I'm starting with a 6 molar solution, so it's a pretty concentrated solution. And I don't have a V2. Now, when I solve for this V2, what the V2 is telling me is how much of the original solution I need to pull in order to add water to it to make the more concentrated, the more dilute solution. So let's do this math real fast. I'm going to slide this over here so I can see my numbers. So I have 1.25 times 0.2 divided by the thing connected to the variable, 6, is 0.04166667, 0.0417 liters, or, move the decimal, 1, 2, 3, 41.7 milliliters. So, it still says describe. Describe means in words. So what would I do? I would measure 41.7 milliliters of the 6 molar solution. How much solute? Add it to a 250 milliliter beaker. Why am I using 250? Because I only need 200 milliliters. So I want a beaker that's just big enough to hold all my stuff. And the key phrase, add enough water to make 200 milliliters of solution. By the way, I failed to mention, SLN stands for solution. And of course, stir. And that's how I make a solution from another solution. Okay?